So during our last class, we have completed our fifth module. So we were mainly discussing about CMM and the types of various CMM. Okay. So as we have done a problem in the class, okay, like regarding, do any one of you remember by I have shared a screen. Do any one of you remember where does this problem comes into action? What was the topic related to this problem which you had done? Any one of you who attended the classes till now, could you just tell me what were the topics we have looked over? Okay, what were the topics we have looked over for the mark, everything? So, what were the topics which you have checked? Can any one of you tell me? Any one of you? Could any one of you tell me what was the topic we have learned? This which is related to this over here. Amit K, could you just tell me the topic which is related to this one? This is regarding the gauge, yeah, gauge. Huh. But only the gauge or anything else? Only the gauge or anything else? See, regarding the cold zone, okay. I hope so you remember regarding the shaft hole arrangement, okay. Regarding the shaft hole arrangement, upper deviation, lower deviation, zero line, all this we have discussed, okay. Then we have done the problem of the class also. So what happens over here is the dimensions. Everyone just note it down in your notebook. Okay, today we are going to discuss about the four basic problems. As per the syllabus, it is mentioned as simple problem solved. So we'll start with the problems now. So we will be doing some problems where, okay, the syllabus it is told some basic simple problems will be asked in the question. Okay, so it is for self-study. Basically, it was for self-study, but as we have completed the portions, we will have a look over it. So the first one is like the question is like the dimensions. Okay, the dimensions. What happens is the dimensions. So the dimensions of the mating parts according to the basic hole system are given below. Where hole is 25 mm, and run is 20, and shaft is 24.97 mm and 25.05 mm. etc. So find the hole tolerance, shaft tolerance, and allowance. Okay, that's what we say. Find the hole tolerance and shaft tolerance. That's what. Okay. So we have to find the hole tolerance and as well as the shaft tolerance. Okay, we are finding the both the cases. So I hope so you remember the equations which we have learned before. It was the hole tolerance and regarding the shaft tolerance and allowance, everything. So I hope so you remember the equations. So what over here it is like the dimensions of the mating parts according to the basic hole system are given as follows. So now we are representing this problem in the respective shape of the shaft and the whole allowance. So we have studied allowance. Other than allowance in that topic, what all topics we have studied? Karthik, could you just tell me what all topics where we have studied in that? Other than the allowance. Okay. Other than the allowance, what all topics we have learned?
Coordinate measuring technique.
Ah, that is in the fifth module. Now we are in the fourth module. We are regarding about the shafts, holes, everything. So with respect to the shafts and holes, what all we have studied? What all the factors we have considered? Can you tell me the terminologies? What were the terminologies? Could you just tell me the terminologies what we have studied?
Gauges അല്ലേ?
Hmm? Other than gauges, terminologies, allowance, tolerance, then what all we have studied? That's what I'm asking. Allowance, tolerance, all that we have studied. So what all we have studied? That's one question.
Accuracy, precision.
Accuracy, precision. Then what else? You're right. You're on the right track. Accuracy, precision. Then what else? other than accuracy and precision? Anyone of you, other than Karthik, anyone of you can you say? Okay, we will go to the yes, right? See, tolerance, upper deviation, lower deviation, accuracy, precision, all this. Okay, the terminology tolerance, bilateral tolerance. So all these factors we have studied. So over here, what we are going to discuss is about the dimensions of the mating parts. Everyone, please note down in your notebook. Okay, the dimensions of the mating parts according to the basic hole system are given as follows. Where hole is 25 mm and run is 25.02 mm and shaft is 24.9 mm and shaft is 24.95 mm. So what we have to find out here over here is find the hole tolerance, shaft tolerance and elements. What we have to find out is find the hole tolerance, shaft tolerance and elements. The solution given is the lower limit of hole is 25 mm and the upper limit of the hole is 25.02 mm. Okay, 25.02 mm. So this we have to write from the solution from the given data. From solution, first we have to write the given data. So this is the basic representation of how do we a problem. So this will be the mark distribution when you are doing any exam or something like the questions are asked. There will be have a mark distribution where we will be mentioning like given is the lower limit of the hole which is 25 mm and the upper limit of the hole is 25.02 mm. So it is already described in the question. So but still we are writing the given data before solving the problem. What all data are able and what all we have to find out. Then what's now it's 25 mm 25.0. Now in the case of shaft, what is the upper limit of shaft is 24.97 mm and the lower limit of shaft is 24.95 mm. Okay, and we have to find out the hole tolerance as well as the shaft tolerance and elements. So we have to find the three factors. Okay, so this can be asked for a 6 mark question like what you for one's whole tolerance shaft. Or in some cases it may be asked for 3 mark question also. Okay, in some cases it may be asked for 2 mark question like only check the whole tolerance or only check the shaft tolerance. All that factors can be considered. So what happens over here is the dimensions of the meeting parts according to the basic hole system are given as follows: where hole is 25 mm and the hole is 25.02 mm and the shaft is 24.97 and we have 24.95 mm. So what happens over here is find the hole tolerance, shaft tolerance and elements where the solution is given. Now just note down the given values where the lower limit of the hole, okay, where the lower limit of the hole is 25 mm, okay, where the lower limit of the hole is 25 mm and the upper limit of the hole is 25.02 mm. And what happens is the upper limit of the shaft is 24.97 mm, where the lower limit of the shaft is 24.95 mm. So now we have to find out the hole tolerance, shaft tolerance, and allowance. Okay, so we know so first what we have to know because it is written in order. In some cases it may be allowance. So to find out allowance, what we have to know, we have to know the lower limit of the hole and the upper limit of the shaft. Okay, so that we have to find. So first in the case we will be checking out the hole tolerance. So we know that in the basic equation we have already learned before that hole tolerance is equal to upper limit of the hole minus lower limit of the hole, that is 25.02 minus 25, which is 0.2 m. Okay, and the shaft tolerance is not the upper limit of the shaft minus lower limit of the shaft, that is 24.97 minus 24.95, that is 0.02 mm. And in the case of allowance, it is we know that allowance is the lower limit of the hole. The lower limit means the lower limit, okay, 25, and the upper limit is how much? Which is 24. But the lower limit of the hole is 25 and the upper limit is 25.02. So in the case of elements, what happens is always we are concerned lower limit. That is, the lower limit of the hole is 25. Okay. So here what we have is the lower limit of the hole minus the upper limit of the shaft. So what happens? What is the upper limit of the shaft? The upper limit of the shaft is 24.97 and the lower limit of the hole is 25 mm. Okay, the lower limit of the hole is 25 mm. So what happens? 25 minus 24, that is the 11, 0.03 mm. So in all the cases there will be all because it is always respected to the precision and accuracy. Okay, precision and accuracy. Now we have discussed the term like hole tolerance, shaft tolerance, and elements. So what is this? It is related with. Now can anyone of you tell me how can you relate it? Okay, okay, how can you relate it? Can anyone of you tell me? Would anyone of you tell me why do we require the tolerance shaft elements in the case of mating parts? Okay, in the case of mating parts, we have learned a topic in that. Nived Kumar, could you tell me? We have learned a topic in that. With respect to tolerance, we have 0.03 mm, 0.02 mm, and 0.02 mm, all that. So we have learned a topic regarding this. Why do we require this tolerance, everything? The fourth module we have learned. Nived Kumar, can you tell me?
Measurement.
Measurement. I agree. There will be some plus and minus values in the measurement. Not an issue. Yes, I agree. My question is, what was the topic related to that in the case of mating parts? So you remember that, right? The whole tolerance, everything we are discussing regarding the mating parts. So in the case of mechanical aspects with respect to metrology. So what happens over here? You just tell me. The mating parts. Do you remember the term named as fits? Yes. Yes. So what do you mean by fit? What do you mean by fit? What do you mean by fit? Nived? My question is to you, what do you mean by fit? Okay, so here we have various types of fit, transition fit, super fit, etc. Rahul, could you just tell me what is the purpose of a fit? How do you check the fit with respect to the above given problem? Uh, could you just tell me? We were told about tolerance, everything, and we have now checked the whole tolerance, shaft tolerance, relevance, everything. So this is mainly coming in the case of mating parts. You remember that?
ആ ഒരു ഇതില്ലേ നമ്മള് ടൈറ്റ് ആയിട്ട് വിറ്റാവുന്ന ഒരു
Yes, that's what. That's what fits. Yeah, you are right. You know the basic concept. That's a fit. Okay. Regarding the tight and holds, in order to have it should be tight fit also, but at the same time, when external pressure is applied, what happens? It should be removed, right? That's what it helps us meeting parts. So that's what we related to the fit. Then what? It has got three types of fits. Do you remember? Transition fit, cross fit, everything. With that respect only, we are doing it. Now, everyone note down the second problem. Note down the second problem. In a limit system, okay, in a limit system, the following limits are specified for a hole and shaft assembly. Okay, the following in a limit system, the following limits are always specified for the hole and shaft assembly. Okay, in a limit system, the following limits are specified for a hole and shaft assembly. That's what happens in a limit system. The following limits are specified for a hole and shaft assembly. So where in the case we have a hole which is 30, is plus or minus 0.02 and plus 0.00 mm, and shaft plus or minus 0.02 mm. Here also we have to determine the tolerance as well as the allowance. Okay, here also we have to determine the tolerance as well as the help, or as well as the hole. Okay, that's what happens. Okay. Now, for determining the tolerance, we have the tolerance of the hole and the tolerance of the shaft in both the cases for determining the tolerance for mainly for determining the tolerance. So, in the case of tolerance of the hole, it is HLH. What do you mean by HLH? Can any one of you say me? I'll ask to Asaf, Mohammad Asaf. What do you mean by HLH? Okay, Sriraj Vijayan, could you just tell me what do you mean by HLH? Ah. Siraj, you are able to see the screen, right? You are see the screen, right?
Yes, sir.
So in the case in the limit system, okay, the first case we are discussing about the tolerance, everything, where we have a limit, everything, and the different types of limits also. Now the second question is, in a limit system, the following limits are specified for a hole and shaft assembly. Okay, in a limit system, the following limits are specified for a hole and shaft assembly. Okay, for a hole and shaft assembly. So what happens over here is, what here we have a hole 30. The tolerance is plus or minus 0.02, upper and higher and lower tolerance. So what do you mean by HLH?
Higher limit of hole,
And double LH?
lower limit.
That's it. That's it. Why are you not confident in saying this? Hmm? We have already learned all this. You remember? See that?
Yes, sir.
Yeah, we have already learned this. Okay, we have already learned this in the fourth module when we are discussing about the tolerance, allowance, precision, accuracy, fits, everything we have already had a view. Okay. So now what happens over here is in the case of determination of tolerance, tolerance of hole is HLH minus double LH, where it is equal to 30.02. It's given. Okay. That's the LH tolerance. That is 30.02 minus 30. Okay. It's equal to 0.02. Then what happens? The tolerance of shaft again HLS minus LLS. So here what is the HLS? 30 minus 0.02 and 30 minus 0.05, which is means 0.03 mm. So these are the tolerance rate for the case of tolerance of hole and the tolerance of shaft. Now, now it will happen a determination of allowances. Okay, determination of allowances. Where allowances is what? Maximum metal condition of hole minus maximum metal condition of shaft. So what happens? The maximum is maximum metal condition of hole, that is 30.0. That's the maximum in the case of hole, and maximal condition, that is how much? 30 minus how much? 0.02. Okay, 30 minus 0.0, that's the maximum metal condition, that is LLH and minus HLS. Okay, that's the maximum condition for determining the element, which is 0.04. So these are the very simple and basic explanation where we can find out the tolerances for the case of limit system and for the case of the meeting parts. Okay, this is a very small representation. So this is a basic way. How do you understand? Okay, how do you understand mainly the dimension aspects, everything? Okay, then we have the third problem. Okay, then we will be having the third problem. So here what happens is small difference. We will be determining the basic size, the tolerance on shaft and hole, and the maximum and minimum clearances. Okay, the maximum and minimum clearances. So what happens is like in this case, the following limits. Okay, the following limits are specified in a limit system to give a clearance between a hole and shaft. What happens? The following limits. Okay, the following limits are specified in a limit system to give a clearance fit between a hole and shaft, to give a clearance fit between the hole and shaft. That's what happened. The following limits are always specified in a limit system to give a clearance fit between the hole and shaft, where hole is equal to 25, which is plus or minus 0.03 minus 0.04 mm, and shaft is 25 raised to what? Minus 0.006 minus 25 minus 0.002 mm. So these are the determine the following. So here I have written the question in the same way that it will be written the given data. So before starting the question, just read the question twice, then collect all the data. What all the data are available in your problem first. So just collect what all the data are available in your problems. After that, just note it down. Then the second stage, just note it down what all the things or what are the factors we have to consider and we have to find out. For finding out how do we achieve it? By putting which all equations it will be applicable or it will be available, we have to check it out. Only then we will go for the solution. So it will be step by step process where you will be able to score the precise amount of marks as per the scheme. Is for your series test, for the university, or whatever exams you write. You will be in order so that you will not miss out anything. At the same time, you will be saving the time. Okay. So what happens over here is the following limits are specified limit system to give a clearance fit between a hole and a shaft, where this is the hole and a shaft where hole is 25. Where hole is 25 is raised to plus 0.03 and hole is 0.00 mm. And shaft is 25, which is raised to minus 0.006 and which is raised to minus 0.020 mm. And we are requested to determine the following factors like the basic size, okay, of the shaft and the hole. Then what happens? The tolerance of the shaft and the hole, and the maximum clearance, okay, maximum clearance for the retaining. So in this case, it is between the hole and the shaft. Since the hole and the shaft are the mating parts, okay, these are the mating parts, okay. So why are we doing the problems with the hole and shaft? Can anyone of you tell me? I'll ask to Saurabh. Saurabh, can you just tell me why do we are doing all this with the hole and shaft? Did we explain it somewhere else? Saurabh? Saurabh, could you hear me? Are you available? Saurabh? Okay. Vishnu AP?
Sir,
Okay. Okay, Saurabh, could you just tell me what is the relation? Why do we do all these problems with respect to shaft and fix?
കേട്ടില്ല ഒന്നും കൂടി പറയാം.
Why are we doing all these problems with respect to the shaft and the hole? What is the factors? What is the factors? What is the factors? Like, okay, sorry. So now Vishnu, can you just tell me what are the factors? Okay, no problem. I'll tell. The following limits are specified in limit system to give a clearance fit between the hole and the shaft, where the hole is 25 plus or minus 0. So what happens here? The basic size of this is the same for both and the shaft. So in order to have a clearance fit between a hole and the shaft, what will be clearance fit? There will be mating of your parts so that it will prevent the rubbing action, everything, and there will be no scratches and wear and removal of the material will be taking place. So here what happens is the following limits. Okay, in this case, the following limits are specified limit system to give a clearance fit between a hole and the shaft, where the hole is 25 plus 0.03 minus 0.00 mm and the shaft is 25 minus 0.006 minus 25 minus 0.002 mm. So determine the following. First one is the basic size, second one is the tolerance on shaft and hole, and third one is the maximum and minimum clearances. So these are the solutions where we have to learn about it. So on the first case, basic size is the same. The basic size is the same for both the shaft and the hole. Basically, the size and the will be the size and the shape will be the following. So the first case, the basic size is the same for both shaft and hole. Okay. So how do you determine it? So first one is B. Okay, determining the tolerance. Okay, here what we have to have. So determine the following is basic size is same for both the shaft and hole. Basically, the size is the same and shaft for hole. Only some amount of tolerances will be applicable in order to what? In order to have a system. Okay, only some type of basic tolerances will be available in order to have a basic system. That's what. The second case, the determinant of tolerance, where we have tolerance on the hole. That's HLH minus LH. Okay, LLH. What happens here? HLH is what? Holes tolerance, that is 25.03 minus what? Sharp's tolerance, that is 25. Okay, that is 25. Okay, 25.020 it is the value. So here what happens is we have taken LLH. Okay, that is 25. So which happens 25.03 minus 25. That's what happens. It's equal to 0.03. Okay, it is 0.03. Okay, that's what. So in the case of here LLH, then the tolerance of shaft, that is HLS minus LLS, that is 25 minus 0.006. Okay, it is in the case of shaft. Okay, in the case of shaft, it is 25 minus 0.006 minus 25 minus 0.0020. That happens. Okay, so higher and lower. Okay, that's what we are saying over here in the case of tolerance of hole and the tolerance of shaft. In the case of tolerance of hole and the tolerance of shaft, then we have the determination of clearances. Okay, then we have the determination of clearances, that is the maximum clearance and the minimum clearance. Okay, then we have the determination of clearances, that is the maximum clearance and minimum clearance. Okay, so in the case of maximum clearance, it is HLS minus LLS and it's equal to 25.03 minus 24.98 is equal to 0.05 mm, and minimum clearance is LHS minus HLS, which is 25 to 25 minus 0.006 is equal to 0.06 mm. So this is what happens in the case of limits and specified limits. Okay. Then the next case is the tolerance for a whole shaft assembly having a normal size of 50 mm as follows. Okay. In the case of 50 mm is also follows. This is what happens in the case of tolerance of shaft. Okay, in the case of 50 mm. So what happens is, okay, what happens is like tolerance of a hole. Okay, it's mainly the tolerance for a hole and a shaft assembly having a normal size of 50 mm as follows. Like hole is that 50 plus 0.002 and it is higher and lower, that is plus 0.00 mm, and shaft is 15. So here what happens, this is the case where we have to determine the following. So all these are very simple and basic problems. We have to just learn the equations, what is the clearance equations, the tolerance equations and everything, and it will not be a very huge question. All it will be for 2 marks everything. So you will be able to score the marks in a very simple aspect. So what we have to understand basically, the clearance, tolerance, precision, accuracy, everything will be under most of the cases 0.5. Okay, everything will be always under 0.5. So it should not have a loose fit, it should have a clearance fit or a transit fit. All that aspect should be there. So it should be always between the there should be no a loose fit. That's what happens. So what happens over here is we have a determination of clearances where we have a maximum clearance, that is the higher into hole minus lower into shaft. So the case of the now first in the first case, okay, in the first case we are taking in the case of a hole. Okay, that's what happens, load and then the shaft. So here what happens is 50.02 and the LLS means the shaft. Okay, so what happens, 50 minus 0.08, that is the lower limit of shaft. Okay, and then the case of maximum clearance is the higher limit of the hole. That's what third difference. So the lower limit, so it is always the maximum clearance is the higher limit of the hole minus the lower limit of the shaft. Okay, the higher limit of the hole minus. So you have to just know the basic equation. You have to just study the equations and then you can just substitute the values and you can find the maximum clearance, tolerance, and allowances, everything. So you have to know just the basic equations. What happens is maximum clearance, that is HLS minus, okay, higher value minus the lower, which is higher limit of the hole minus the lower limit of the shaft, that is 50 point. You can see here 50. Okay, higher limit means it is plus 0.02, that is 50 plus 50 plus 0.02, that is 50.02 minus lower limit of the shaft, that is 50. Lower is down, so it is minus 0.08. So 50 minus 0.08. Finally, it comes into 0.10 mm, and then we have a minimum clearance. Then we will be having a minimum clearance. Okay, then we will be having a minimum clearance, that is lower limit of the hole minus higher limit of the shaft. But that is the lower limit of the hole is 50 plus 0.00, that is 50 only, and then the higher limit of the shaft, which is 50 minus, okay, higher limit is top, which is minus 0.05. So 50 minus 0.005, which is equal to 0.05 mm. That's what happens in the determination of clearances. Then we have the determination of tolerances. Okay, then we have the determination of what? Then we have the determination of tolerances. So the tolerance of the hole. Okay, then we have the tolerance of the hole. So tolerance of the hole is higher limit of the hole minus the lower limit of the hole. That is tolerance of the hole is higher limit of the hole minus the lower limit of the hole, which is equal to 50.02 minus 50.00, which is equal to 0.02 mm. And the tolerance of the shaft is higher limit of the shaft minus lower limit of the shaft, that is 50 minus 0.05 minus of 50 minus 0.08, which is equal to 0.03 mm. That's what happens in the case of the tolerance of the shaft. Okay, then what we have, Okay, then what we have is the determination of allowances. Okay, determination of allowances. So we have the determination of allowances. So what we have in the case of determination of allowances, allowance is equal to the maximum metal condition of the hole. Okay, allowance is equal to the maximum metal condition of the hole. So in this case, what happens in the case of allowances? It is the maximum metal condition of the hole minus maximum metal condition of the shaft. Okay, maximum metal condition of the hole minus maximum metal condition of the shaft, which is equal to the lower limit of the hole minus the higher limit of the shaft, which is 50. Okay, because it is the lower limit of the hole is 50 c 50 plus 00, that's why 50. Then the higher limit of the shaft is 50 minus 0.005, that's why 50 minus 0, that is 0.005 mm. Then we have the determination of mmls. So what is that? Mmls of a hole and mmls of a shaft. Okay, so that's what maximum. Okay, maximum what? Maximum metal level. Okay, and minimum. So what happens? Lower limit of the hole is 50. So what we know? Maximum into the hole, lower, which is equal to lower limit of the hole. Maximum is lower limit of the hole. That is, so both are what? 50. Okay, almost related to 50, and the shaft is higher into the shaft is 50. That is 49.05. This is what happens in the case of determination of mml. Okay, so mml of hole and shaft. Okay, then we have the type of fit. Since both the maximum and minimum clearance values are positive, it can be concluded that the given pair has a clearance fit. Could any one of you tell me what are the various types of fits available? I'll ask to Sarun Rajiv. Sarun Rajiv, could you just tell me the various types of fits available? We have available.
Awesome.
Could you just tell me the various types of fit available? Sarun, did you hear my question?
Yes, sir.
No. Could you just tell me the various types of fits available?
Clearance fit, പിന്നെ
Mm.
interference fit,
Mm.
പിന്നെ transition,
Ah. These are the three types of fits. So why do we say clearance fit in this case? Why do we say clearance in this phase? Why do we use clearance in this case?
meeting loose ആക്കെ.
Ah, yes. There's always a clearance occurring between them. One word can say. Please try to speak in English. If it's a mistake, also not a problem. Okay. Always the medium of communication in the face of professional should be English. Okay. So what happens? There's always a clearance between the two. So now, what is the difference between the clearance fit and interference fit? I asked to Nisab. Nisab, could you tell me what is the difference between the clearance fit and interference fit? Again. Nisag, are you available over there?
Yes, sir.
Yes, tell me. What is the difference between clearance fit and the interference fit?
Clearance fitല് tolerance zone of hole is
Okay. That's already told by Saurabh. Sorry, Sarun. Now you tell me about the interference fit. The name itself
tolerance
represents
zone
everything,
of
right?
tolerance zone
Okay.
of hole
Tolerance
is
zone.
entirely below the tolerance zone of the shaft.
When the mating is taking place, what will be happening? That's the main thing over here. Today we are doing about some small simple problems where we will be discussing about the mating. So what my question is, how it is related to the mating aspect with respect to the interference fit, how it is related to the mating aspect.
Sir, interference occur
Hmm.
shaft in the hole between.
That's what interference. Okay, that's what interference will be occurring between the shaft and the hole. That's it. Now, the case of transition fit, I'll ask to Fateh. Could you just tell me the transition fit? Mohammed Fateh, could you just tell me the transition fit?
Sir.
Just tell me transition fit.
Transition വിറ്റാ
Yes.
ക്ലിയറൻസിന്റെ ക്ലിയറൻസ് ഫിറ്റ്
Hmm.
ടോളറൻസിനുണ്ട്.
Okay. My question is, with respect to the meeting parts, what is the aspect of the transition fit?
ഫോർ ടോളറൻസ്
Tolerance everything. So what will happen?
അറിയില്ല.
Okay. No. The shaft and the hole overlaps. Okay. The shaft and the hole always overlap. So that's what. Okay. So this is what happens. So I'll just have a summarize up. Everyone just note down. Okay, just note down what I'm going to say. So here what happens, hole tolerance is always upper limit of the hole minus lower limit of the hole. So just remember that in the case of hole tolerance, we have to always have the upper limit of the hole minus the lower limit of the hole. And the case of shaft tolerance, it is always the, please note it down in notebook. I hope so you have done the problems in your notebook. Okay, so I hope so I will be providing an extra assignment for that with the different values and everything, so that you can do and submit it later. Okay, so what happens over here is like what happens, the dimensions of the mating parts according to the basic hole system are given as follows, where we have a hole, and that is that we know that the hole tolerance, that is upper limit of the hole minus the lower limit of the hole. And the case of shaft tolerance, it is upper limit of the shaft minus the lower limit of the shaft. And in the case of allowance, it is lower limit of the hole minus upper limit. So my point is like, if you basically study the simple equations, what happens, it will be done. Okay, you can be done over that. That's what. Then here what happens, the limit system, you see tolerance of what, higher limit of the hole minus lower limit of the hole. Okay, that's the tolerance of hole is higher limit of the hole minus lower limit of the hole, and tolerance of shaft is higher limit of the shaft minus lower limit of the shaft. And then in the case of determining the elements, what, maximum metal condition of the hole minus maximum metal condition of the shaft. That is always the maximum condition. That's the lower limit of the hole minus higher limit of the shaft. That's what happens. Then what happens over here? Here we have the basic size always of the basic size are same for both the shaft and the hole, but there will be allowance and tolerances given. So what happens in the case of tolerance of the hole, it's always a higher limit of the hole minus lower limit of the hole. And in the case of tolerance of the shaft, it is the higher limit of the shaft minus the lower limit of the shaft. And in the case of clearances, it is the maximum clearance, which is equal to the higher limit of the hole minus lower limit of the shaft, and the minimum clearance is the lower limit of the hole minus higher limit of the shaft. That's what happens. Then in the case of tolerances, this is what happens, like the maximum clearance and the minimum clearance. That is again we have told here. Then the tolerance of the hole and the tolerance of the shaft. Then in the case of allowances, what happens? The maximum metal condition of the hole and the minimum metal condition of the hole. Then the case of mm's, that's the lower limit of the hole, and shaft is maximum metal limit of the maximum metal limit of the hole is lower limit of the hole is 50 mm, and the what happens, the maximum limit of the hole is shaft is equal to the higher limit of the shaft is equal to 50 mm, 49.05. Since both the maximum and minimum clearance are positive, it can be given as per clear figure. So these are the basic equations which has been given for doing a small problems related to the shaft and the hole with respect to allowances, limits, precision, accuracy, everything. Okay, okay then we'll stop the class. We'll continue the next class.